So this is lesson number 95 in Algebra 2, called More Nonlinear Systems. And it's so much fun to do nonlinear systems. Nonlinear systems are obviously pictures of equations that do not give you a straight line. So they will give you either like a hyperbola, parabola, a circle, an ellipse, all kinds of other figures there. And we've done some that are like these, but we're going to continue on. We're going to do the first example, and this should be more of a review than actual new stuff. So if we're given two equations, and each one of those equations is going to allow me to draw a picture, and what I'm interested in is where these two pictures or drawings intersect. Where they intersect, that is what my x and y values are. And sometimes they're going to intersect in one place, sometimes 2, 4. So you have a lot of different ways that they're going to intersect. In fact, the top equation is a straight line, and the bottom equation is what's called a hyperbola. So what we're going to do here is we are going to find out what x and y are. And what you've done up to here is you've done a system of equations where you can choose whether you're going to do elimination or substitution. The only way you're going to be able to do elimination is if you have an x and a y separated by a plus or a minus sign, and here as well as here, or multiplied together here as well as here. But you can't have one that's separated by a plus or minus sign and one that's multiplied. You can't use elimination if that's the case. So if that is the case, and you're going to have to use some sort of substitution in order to make this work. So you're going to look at the easiest equation, which in this case it's going to end up being that one, and you're going to rewrite that as x equals 4 over y. Now you could have written it as y equals 4 over x, but we'll just do it this way since this is the way the book is doing it. And then I look at my top equation, and whenever I see an x value, I'm going to put 4 over y in its place. So let's do that. Okay, and at this point I have, let's get this stuff out of the way, I have one variable. So let's go ahead and multiply this through. Okay, now if I'm going to continue to solve this, I'm going to need, well, how about if we do this? How about we could find common denominators, but that wouldn't get rid of the fraction. But how about if we multiply this entire thing by the common denominator, which would be y. Okay, so we do that, and we get y times 24 over y minus y times y equals 5 times y. Okay, so what happens here? That cancels with that, and I'm left with 24 minus y squared equals 5y. Okay. Now once I've got to that place, then I can rearrange my equation as negative y squared minus 5y minus 24 equals 0 plus 24 equals 0. And then if I want to make this positive, I just make it positive, but I have to change the sign of everything else in order to do that. Okay? Then I can look and say, well, can I simplify it into two binomials? And it sure would be nice if I could, and I can. And my y value then is 3 and 8. Or I should say negative 8. Okay, negative 8 from there, 3 from there. Alright, so let's move all of this out of the way. Okay, so we've got some room there. Yeah, we don't even need that. Okay, so we found out y is 3 and 8. Alright, got to find out what x is. So I look at one of the equations up there that I started with. Doesn't matter which one, but obviously I'm going to take the simplest one. And I'm going to put a 3 in for y. And x equals 4/3. So when x is 4/3, y is 3. Now I'm going to take the same equation and I'm going to put in 8, or negative 8, I'm sorry. So x times negative 8 equals 4. So x equals negative 1/2. So when x is negative 1/2, y is negative 8. So what that's telling me is that when those two equations, the two that I had one, I had 6x minus y equals 5, and then I had this one. So these two equations, they cross each other at two places, there and there on the graph. So really, what this looks like, just so you have an idea of what we're looking at here, is let me get a graph here. Graphs are always helpful. Alright, so what happens is I've got a graph that kind of looks like that, and kind of looks like that, and then I've got a line that goes like that. So these two places are where they cross. Okay, so this point right here is supposed to be negative 1/2, negative 8, and this is supposed to be 4/3, 3, but I just drew it just real quick as an example, so they're not going to be obviously exact. Alright, let's look at 95.2. Okay, now notice my x and y are separated by a plus or a minus sign here and here. That being the case, I can use elimination or substitution, but when I notice I have a positive y squared and a negative y squared, I'm going to go ahead and use elimination. Now, one of the things that you have to be careful of is you may not be able to look at that equation and determine that the top one is a circle and the bottom one is a hyperbola. You may not even know what a hyperbola is, but the fact remains you need to make sure that you find all of the answers. So, in this particular one, we're going to have 4 different places where these lines cross each other. In fact, just to kind of give you an idea, we're going to have something like this, and this, and this. So they're going to cross at 4 different places like that. So just to give you an idea of what we're looking at, I'm not asking you to graph these necessarily right now unless the instructions say to graph it, and it doesn't. It just says solve it. So let's go ahead and use elimination. Using elimination, we don't have to multiply by anything because these are already the same. So we're going to get 3x squared equals 3. So x squared equals 1. Okay. And x, square root of both sides, we get x equals plus or minus 1. Alright. Whoops. Plus or minus the square root of 1, which is 1. So we get plus or minus 1 for our x values. So that means we're going to get a 1 for an x and a negative 1 for an x. So let's take all that information and plug it in to the original problems that we have up here. So let's plug it into the top one. So we're going to plug a 1 in, and then we will plug negative 1 in. Okay, so we'll do both of those. Okay, so let's go ahead and plug the 1 in. and we get 1 plus y squared equals 9, so we get y squared equals 8. Square root of both sides, y equals plus or minus 2 square root of 2. Because we take the square root of 8, and square root of 8 simplified is plus or minus 2 square root of 2. So see what we got here? When we plugged 1 in, we got 2 y values. So what does that mean? That means that when we plug in 1, we get 2 square root of 2, and we plug it in, and we can also get negative 2 square root of 2. So there's 2 answers right there that we get by plugging in 1. So let's plug in negative 1, and let's do this in green just because it'll make a big contrast to what we've got. So 1 plus y squared equals 9, y squared equals 8, square root both sides, and we get plus or minus 2 square root of 2. So when we put negative 1 in, we get 2 answers. When we put negative 1 in, we get 2 square root of 2. And when we put negative 1 in, we can also get negative 2 square root of 2. So see what I've got there? I've got 4 different answers here. So when I graph it, let's get rid of all this junk here and get our graph up here. So when I graph it, I said I get negative 1, 2 square root of 2. So I'm going to get a point somewhere around here, a point somewhere around here, 1, down here and down here. Okay? So when I graph those two, I'm going to get this, I'm going to get that, and then I'm going to get a circle like that. And those are the points, those are the 4 points where I'm going to cross. Okay? Oh my goodness, that is it for this lesson. Okay, not too much there, but really that's all you're doing, so not too bad.